Okay, fifth lesson and the final lesson in the initial atomic structure topic. Today we are focusing on all things distillation. Over the last couple of lessons, we've looked at different separation techniques. We've looked at chromatography, filtration, and crystallization. So, quick little starter. Can we name any of this equipment? I'm going to give you the kind of setup of this one. What was it that we were looking at? So we've got a few things across the top just there. Oh, how good's the drawing going to be on this? Oh, hello. That just I'll draw that other leg so you can hopefully maybe name it. And those ones there. Okay, so going across the top, we have got, and if you've had a little stab at this, hopefully you've got the idea of a funnel, a beaker. Yes, that was a beaker. Thank you very much. We've got our chromatography setup just here. Difficult word, chromatography. Chromatography, and a difficult word to squeeze in, but red covers the purple on the side. Hooray. We've got our friend the Bunsen burner that needs a capital letter down here. Lots of different bits of a Bunsen burner, actually. We have the tube coming in. We have the collar down the bottom, in case you didn't know that, and the chimney. Everyone loves a chimney. And then obviously the flame comes out the top. This little guy just here with the 3 legs is our tripod. And then we've got our 2 different types of tube. Okay. The big brother of the tubes is the boiling tube, and the little tiddler on the right is the test tube. So we have a boiling tube and a test tube. So looking at all things distillation today, lots more equipment to mention, and we're going to recap over a few processes as well. So, learning objectives: to understand how distillation and fractional distillation, that links to the organic chemistry topic later on in GCSE, how they can be used to separate mixtures of liquids, and we're going to explain how simple distillation works. If you want more detail on fractional distillation, you need to go and find that elsewhere, but it's just to mention that distillation links in with that. So, first task, and again, a thank you to Twinkle. Twinkle have put lots of resources out for free at the moment, and this is just another example of their great graphics and things that are bunged in. I've made these slides applicable to my students, so these are kind of a watered down version of the Twinkle resources with some extra tasks and keywords and other things bunged in. That's why they look slightly different. So, you are stranded on a desert island with no source of fresh water. Drinking salt water will kill you. How will you stay alive? Crumbs. So you have 2 minutes to come up with a plan. Pause the video, have a think. Now, the desert island was surrounded by salt water, so what you have got to do is separate the water out from the salt water, and you're going to do that by using distillation equipment. Now, there's a link to another YouTube video just here, so I would watch that now. So stop this video, watch the video about distillation, and then have a look at completing these tasks. The link will be in the description below. So, simple distillation is used to separate substances that have things dissolved in them. Here, the task is asking you to use the words below to label the distillation apparatus. So, having seen the video, you've now got to label this equipment. And here we go. So the thermometer is at the top. That's going to measure the temperature. Notice very deliberately the bulb of the thermometer is right next to where the gases are going to pass down into the condenser just there. So you're measuring the temperature of the gas at that point. Okay, in the round bottom flask is the solution of food colouring and water. That's being heated up by our Bunsen burner at the bottom. The gases are going to move and they're going to go down into the condenser. Now, the condenser has water going in at the bottom and water going out at the top. And that is very deliberate, such that cold water comes in at the bottom, and then any hot water, because if it starts to heat up, because of the gases coming through it, that can get passed out. And the water goes in at the bottom and out at the top in case any gases get trapped. If you had water coming in at the top and out at the bottom, if there was any gas in the water, or if the gases going through the condenser were hot and they formed some gases in the jacket around the condenser, then any bubbles or any gas would get trapped within the condenser. So it's very deliberate that the water comes in at the bottom and out at the top. Then there's a beaker sat on top of a tripod, so maybe a little bit more information just here we could give. And the pure water is left over at the end. And we actually call that the distillate that comes off. Okay, it's filtrate when we filter, it's distillate when we do distillation. Oh, another task, thick and fast. This is all recall of stuff that you should have already done and stuff that cropped up in that other video. So, describe how distillation enabled the mixture of food, colouring and water to be separated. In your answer, can you include the following terms? Condenses, evaporates, cooled, heated and boiling point. So obviously you need to have maybe gone back over your notes from when you did this in class, gone back through the video, maybe you've gone on to BBC Bitesize and found out about distillation, and you've got to use those key terms. Now, this is a really common exam trick. They quite often ask you to structure an answer and give you words in which need to be included. What would happen if the mixture was heated to a temperature higher than the boiling point of both substances? So have a think about that. And how could you separate a solution that contains several different liquids? And that's those of you that have done the organic topic and have studied fractional distillation, your brain is already kind of giving you notice that the answer might lie there somewhere. Okay, pause the video, have a go at those questions. And here are the answers. So, number one, describing how distillation enabled the mixture of food colouring to be separated and using those key terms. So, simple distillation enables a liquid to be separated from a solution. This solution is heated until the solution with the lowest boiling point starts to evaporate. Think about it. You're starting everything off at room temperature, and as you heat it, the compounds in there are being heated up. And imagine a kind of the thermometer rising. Now, as it hits the boiling point of the first substance, let's say there's two substances in there, and one of them has a boiling point of 50 degrees and the other one has a boiling point of 100 degrees. When you start to heat the mixture, it doesn't just suddenly hit it like 100 degrees, it heats up. So as the particles get more and more energy, as it gets to 50 degrees, which is the boiling point of one of the substances, at that point, only that substance has enough energy to break away from all the other particles around it and to evaporate and turn into a gas. The vapour is cooled and it condenses. So that happens in the condenser. So it turns back into a liquid. That's what condensing means. This liquid can be collected, leaving the rest of the solution back in the flask. So that would be the thing that has the higher boiling point. Now, what would happen if the mixture was heated to a temperature higher than the boiling point of both substances? So the example I just said, what if you had a substance that boiled at 50 and another substance that boiled at 100? So here, if we suddenly had it at 200 degrees, now obviously that would be hot enough to boil both of them, and they would both evaporate at the same time, and that would be completely pointless because we'd be left with a solution that contained both of them. How could you separate a solution that does contain several different liquids? Well, all of those liquids are going to have different boiling points. So we would use a process called fractional distillation. So we would heat it up slowly as it got to the boiling point of the first one, the first compound, let's say 50 degrees. All of that substance would come off first. When all of those particles of that compound have evaporated, then the liquid would carry on heating up. Let's say it then gets to 100. At this point, you've changed the beaker underneath the condenser. So it's now empty, and then it would only allow in the particles of the compounds that are boiled at 100 degrees. And then let's say you then kept going, you had something that boiled at 125, 150. So you'd have to change the beaker at the bottom to make sure that you didn't get a mixture of things. Right, it's all about the task today. Can you explain why a mixture of water and ethanol can be separated? So 3 marks, so usually this would be 3 minutes. Give yourself 3 minutes. So ethanol and water have different boiling points. If you don't believe me, go on to the internet and search boiling point of ethanol, boiling point of water, and see what you find. The solution with the lowest boiling point will reach its boiling point first, because remember, everything's starting from room temperature and being heated up, and that's going to start to evaporate. This can then be condensed and collected, and the mixture will be separated. Now, once all of the thing with the lower boiling point, in this case it's ethanol, when all of the ethanol has been evaporated, only then will the liquid remaining in the flask continue to heat up. Okay, it's actually amazing when you watch distillation take place to watch the thermometer stop at a temperature, even though you know you're adding loads more heat, just seeing that temperature stop whilst all of that ethanol in this case evaporates. The distillation of ethanol is very dangerous, though. You have lots of a very volatile and flammable gas floating around, so you wouldn't do it with a Bunsen burner. You would use another form of heating, otherwise you're going to get a big bang. And then can we summarise everything from today? So everything from this lesson relied on you going away and doing a bit of research yourself, maybe watching a video on distillation, looking at some key words and terms, maybe using a resource like BBC Bite Size or lots of other resources online. And can you summarise that information, put it into bullet points, summarise it onto maybe a small sticky note, or making some flashcards? I know I've banged on about these 3 methods over the last 5 lessons, but they are really important and they really do work. And making notes and going back over your notes and reducing your notes is such an important, such a valuable way of revising to help stuff stick in your long-term memory, not just your short-term memory. So there we go, first topic done, and I will see you again when we do the periodic table topic.